Hey, Mitch. Hello?
Hello.
Hey.
Hello?
Yeah, can you hear me okay?
Yeah.
Okay.
I accidentally clicked the mute button.
Oh, I've been having all kinds of problems. I just got off of a session where right towards the end I lost my internet connection. First the audio went out, and then I called the person on the phone to do audio, and then he couldn't see my screen anymore, and I realized my internet was out. I had to completely reboot my system. So hopefully we won't have any problems like that.
All right. Did you get my email?
I did, and I'm glad I had a chance to look at it first. These are a little tough,
Yeah.
but not once you get the hang of it. The whole trick on these is to try to, when I first looked at it, I had to think about it for quite some time to figure out how to do it. And once I did the first one, the others weren't that hard. It's another way to write secant.
Isn't it cosine?
Okay, so this now becomes 1 over cosine of 25 degrees times the sine of 65 degrees minus 65 degrees. What's another way to write cosine of 25 degrees? Using the cofunction property.
Isn't it secant?
No,
Or no?
not the reciprocal property, the cofunction property.
Oh, sine.
So that's sine of what?
Sine of 65?
Right. It's always, the cofunction property is the function is always equal to the cofunction of 90 degrees minus the theta. So the cosine of 30 would be the sine of 60, cosine of 40 would be the sine of 50, so forth and so on. Okay? What's another way to write sine of minus 65 degrees using odd-even function?
Wouldn't it be just negative sine of 65?
So now we have the negative sine of 65 divided by the positive sine of 65. Minus 1.
All right.
Okay. So at no point did we have to know what the sine, secant, or cosine of those angles are. And that's kind of the point of these problems, is to do these without your calculator. These are kind of odd angles. It's another way to write secant squared of pi over 2 minus theta.
Is it cosecant?
Yeah, just remember the cofunctions are the function with a co in front of it.
All right.
Sine, cosine, secant, cosecant, tangent, cotangent. So if you want the cofunction of cotangent, it's tangent. No, right. It goes both ways. So that's the cosecant squared of theta minus cotangent squared of theta. This time they don't even put an angle in there. So we know it's not critical to know the angle. Give me the 3 trig Pythagorean identities. First one is sine squared plus cosine squared. What's that?
Equals 1.
Second one is what?
Is it cotangent plus secant? Or cotangent plus 1?
Here's the way I remember it. These are the important two that you have to remember.
All right. Tangent. Okay.
Okay?
Yeah.
First one you know, the second one's a little different, but it involves tangents and secants. Okay? And the third is merely the cofunctions of the second. So what's the cofunction of tangent? It's cotangent squared plus 1. And the cofunction of that is cosecant squared x. 1 second, Mitch. Hello? Sorry about that. Okay, so these are the three trig functions, or rather they're called the Pythagorean trig functions, because you get this one from the Pythagorean triangle, or the Pythagorean theorem rather, and you get the other two also from the Pythagorean theorem. But the only two I memorize are that one, and then I know the third one is the second one with the co in front of the words.
All right.
Okay, which leads us to that one. So, using substitution, how can I write this expression that we have up here?
Cosecant squared. Wait, no, it's.
Be better to substitute for that because we've got that fully defined.
Yeah, so it's just parentheses cotangent squared x plus 1.
Is that equal to?
1.
It's another way to write cosine of 325. This is a bit more difficult. You have to figure out which identity to use to solve these. First of all, let's change cosecant. What's another way to write cosecant of minus 55?
It would just be cosecant 55 because isn't it an even property?
Well, it's the reciprocal of what?
Cosine. Sine.
Remember, in your reciprocal properties, there is only one co in each pair.
All right.
And don't confuse that with cofunctions. It's not the same as cofunctions at all. In other words, we have our reciprocal functions and we have our cofunctions. Sine is the reciprocal of cosecant. There's only one co there. Cosine is the reciprocal of secant. There's only one co in that pair. And finally, tangent is the reciprocal of cotangent, and there's only one co in that pair. It so happens that these are also cofunctions, but these two are not, the two above. Okay, the cofunction of sine is cosine. And remember, the cofunction properties are the ones where it's equal to 90 degrees minus theta. But the reciprocal properties carry the same sign, plus or minus sign. So if I'm going to convert these, probably the best way to do most of these, if they're not squared, in other words, the second one, we were looking at a squared. Well, when I'm looking at trig functions squared, I'm going to look to the Pythagorean identities. When I'm looking at trig functions like this, first of all, I'm going to see if I can put it into sine or cosine. especially when the other part of it's cosine.
All right.
So what's the reciprocal?
Sine.
And now what's sine of minus 55? Same as.
Isn't it negative sine?
Because it's odd. Okay, so sine of minus 55 is the same as minus sine of 55, just based on the fact that it's odd, not even.
All right.
Now, this next step is the hard one. What's the cosine of 325 the same as?
Isn't it the same as cosine of 35?
Minus 35. In other words, if I draw the unit circle, if I go all the way around to 325,
I thought cosine was positive in the.
We're getting to it. Hold on. There's a couple of conversions that need to be made here. Do you see why the positive angle of 325 is the same as the negative angle of minus 35?
Yeah.
Okay. In other words, they're coterminal. So all we're doing is subtracting 360. You can always do that. You can add or subtract any multiples of 360 that you want. So I can write this as the cosine of minus 35. Is that odd or even?
That's even.
So that's the same as the cosine of positive 35. Now, based on the cofunction property, what's the numerator? Can I make the numerator into 55 degrees?
Yeah.
By replacing it with sine, because they're cofunctions. So this whole thing becomes the sine of 55 in the numerator and minus the sine of 55 in the denominator, minus 1. So all of these problems, it looks like we don't really care what these angles are as long as they are in this relationship. In other words, you couldn't just say x and y, but I think you can see where we have to go to solve these. Now, I haven't solved the rest of them, but using that principle, what's the first thing we would do?
We would get sine, cosine.
So tell me the first thing that I want to do with problem number 4.
So I'm going to switch cosecant to sine.
Okay.
All right, like reciprocal. So.
Right. Okay, so we have this. And cosecant is the reciprocal of sine, so I'm going to put it there. And now you can tell that since we're dealing with two negative angles, we're going to have to use the odd-even property. We're also dealing with an angle that is outside the unit circle, so we're going to have to do something to put it inside the unit circle. And by the time we're done, we're going to either have cosine and cosine or sine and sine, and they're both going to be the same angle. And I'm betting this is either -1 or +1. So let's go through it step by step. What can I replace cosine of -400 with?
Just cosine of 400 because it's an even property.
Okay, and then what can I do? I don't know. I want to work with inside the unit circle.
And then it would be, because it's 40 over 360, so it's cosine.
It's -40 is the first step.
Right.
In other words, I add 360 to that. What do I get? -40. And then because cosine is even, that's the same as cosine of 40. Okay?
All right.
Now, that's the same as minus sine of 130.
All right.
Minus sine of 130 is the same as what?
Doesn't have a reference angle of 50,
Uh-huh.
so it'd be
So
sine
it's
of
the same,
50.
and it's second quadrant. So I can just replace the 130 with 50, leaving the negative sign out in front. Okay? In other words, when I go from second quadrant to first quadrant with sine, it doesn't change the plus or minus sign.
All right.
Okay? Now how can I rewrite either one of these? Either the numerator or the denominator, and it doesn't matter. Use what?
Just change the cosine to sine, or 1 over.
Not 1 over. Remember, we're using
No, yeah.
Cofunction Properties, so
Yeah.
same as sine of 90 degrees minus 40.
Yeah.
Again, negative 1. All right. Now, the first thing I notice about this problem is that they're squared. Everything's squared. And what's the reciprocal of secant?
Cosine.
Right, and that's cosine there. So if I turn it into reciprocal, immediately have the cosine squared of 38 over the cosine squared, subtract 360 from that. 52.
Yeah, 52.
Well, that's too bad. You see why I said that, right?
Yeah.
In other words, it would have been easier if those numbers were the same. The fact they're complementary is going to come into play here.
All right, then.
Well, let's see. What happened? Let's see. The reciprocal of cosecant is sine. So I can write that as sine squared of 52. What to do with cotangent squared? Thinking. Let's start from scratch here. Well, these things can be a little bit like, you haven't gotten to verifying trig identities yet?
No.
You know, verifying trig identities is a little bit like this problem. You have various directions you can go, and if you go in the wrong one, you're kind of in trouble. Or you go off in a direction that isn't useful. So let's make that change. the cotangent of 218 is the same as what?
Is it?
That's a third quadrant angle.
Yeah.
Leaving it in cotangent for the moment.
Wouldn't it be cotangent squared of 38?
Yeah. And since it's third quadrant to first quadrant, we don't need to change its sign. In other words, the cotangent of 38 is exactly the same number as the cotangent of 218. So now we have a lot of same number stuff here. This became cosine of 38 over cosine of 52. Squared. And what does this become? Let's see. The cosecant puts the denominator as sine of 52. And cotangent is sine over cosine. No, it's cosine over sine. So it's cosine squared of 38 over sine squared of 38. And cosine squared of 52 is the same as sine squared of 38. And now, in order to subtract those two fractions, I have to find the common denominator, which is sine squared sine squared. Okay, we're making progress. Now we have a common denominator, and the result is sine squared cosine squared minus cosine squared of 38. This is sine squared of 52. This is 52 here, and this is 52 here. And it's all over this denominator. Now we can factor out the numerator, and that's going to be useful because we're going to factor out a cosine squared of 38 leaving behind sine squared of 52 minus 1, and that's all over sine squared of 52 times sine squared of 38. That might not have been a little clear because I didn't need that there. You see how I get to this step?
Yeah.
What can I replace this with?
Couldn't you replace
Your first trig, Pythagorean trig identity. If sine squared plus cosine squared equals 1, then what does sine squared minus 1 equal?
cosine squared?
Negative cosine
Oh
squared.
yeah, negative cosine.
Of 52. So it's negative cosine squared of 52 And using the cofunction property, this is the same as sine squared of 52, or is it? And this is the same as sine squared of 38. So again, we get minus 1. Question is that true? Now let's look at it. We know that sine equals cosine of 90 degrees minus theta. So does sine squared of theta equal cosine squared of 90 degrees minus theta? Yes. Because all I've done is squared both sides. So that step was legit. I can replace that with sine squared of 52, and I can replace that with minus sine squared of 38, and now that cancels with that cancels with that, minus 1. Wow, that was a toughie. You said this is an honors class?
Oh, this is just regular.
This is regular pre-calc trig.
Oh, this is regular trig, yeah.
Right, no, I know. Yeah, I meant that. This is pretty tough to be getting this early without getting into the... I rarely encounter... And you're Chatfield, aren't you?
Mm-hmm.
Huh. I wonder if this is a new curriculum, because I've worked with a lot of Chatfield trig students, and I don't remember getting this tough before, this early. But that's okay. Yeah, what you want to notice about this kind of stuff is, well, 42 is the complement of 48, right?
All right.
So I can use cofunction properties here. And we're dealing with squares, so we're probably going to have to use trig identities also. So let's begin by listing our trig identities. What's the trig identity that begins this way?
Minus 1.
Plus 1.
Plus 1?
Equal
Okay.
against squared. And the second one?
And just cotangent. Is this one minus 1?
No, this one's exactly the same. For
Oh,
some reason, and I've never understood this, for some reason the book reverses these two. In other words, the book will give you this as the second one, and for the third one they'll say 1 plus cotangent squared x. And I just have never gotten it because it's so much easier to remember this way. This is exactly the same as this, only using the word co in front of each trig function.
All right.
Okay. So, given that we can relate tangent to secant, and given that cosecant is the cofunction of secant, let's begin there. How can I relate cosecant to secant? In other words, let's change that to secant of something. So we have 4 plus what?
Is that secant 48?
Secant squared of 48.
Yeah, secant square of 48.
And then now we're looking at a tangent squared and a secant squared. We're probably going to need this identity. What is secant squared minus tangent squared equal to?
Plus 1.
Right. And that's the thing is, you know, this, I said this is hard. This really is very, very similar to verifying trig identities, which is what you usually do next. This might just be a preliminary way to get you to do that. Because when you're verifying trig identities, you frequently never run into these things in this manner. Okay, so +1 means the answer is 5, okay?
Yeah.
But what I'm saying is that the third one is sine squared plus cosine squared equals 1. But what they give you is stuff like, this is what you see. And you have to figure out what to replace that with. They don't give it to you in the way that they ask you to memorize it. It's too easy that way. Just like in this case here, they're given a secant squared minus tangent squared. Well, we need to know that that's probably going to relate in that manner because that's the way you relate tangent squared to secant squared. If we were dealing with cotangent squared and cosecant squared, we'd look to that one.
All right.
Yeah, usually after you memorize these first 11 trig identities, the 6 reciprocal and the 2 quotient and the 3 Pythagorean, the next step in trig generally is to start verifying trig identities, and it almost looks like they've changed the curriculum a little bit.
Yeah, they might have.
Yeah, this is the first year I've seen this new curriculum. I kind of like it because it teaches you, it's almost like a preliminary step to verifying trig identities. Most people hate verifying trig identities. But I can tell you right now that if you know your first 11 trig identities really, really well, it won't come that hard to you. It's a little bit of a puzzle. You kind of have to guess, and sometimes you can go in the wrong direction. It's 4:32. Do you want to quit or you want to keep going?
Can we just quit? Because I have work at 5, so.
That's fine.
Right.
No problem. I hope you have the idea. It's just
a
combination of cofunctions, odd even functions, and your trig identities. And eventually you find the right substitutions for these. It's a bit of a puzzle, but it's kind of a fun little game to do.
All right.
All right, Mitch, I'll let you go.
Thank you.
Talk to you next Wednesday, right? Wednesday at 6? Or is that changing?
Yeah, can we just change it to